Good evening, everyone. A warm welcome to you all for another exciting session of Wisdom Waves 1.0, proudly organized by IEEE WI Affinity Group in collaboration with other IEEE chapters of University of Luna. It's wonderful to see so many eager minds ready to learn and grow together. Let's jump right in and make the most of this amazing opportunity. Today's topic is all about something vital in digital world, the API security. As apps and systems rely more and more on APIs, it's crucial to know how to keep them secure. In today's session, we will explore how API work, the risks they face, and the best ways to protect them. It is a must-have skill for anyone interested in this technology. Now, it's my pleasure to introduce our today's speaker, Mr. Pasan Abeysekara. Mr. Pasan Abeysekara is a final year computer engineering undergraduate and a former software engineer intern at WSO2, a leading technological company known for its contributions to API management and security. With hands-on experience in real-world development environments and a passion for cybersecurity, Mr. Pasan brings a unique blend of academic insight and industrial knowledge to the table. So, without further delay, it's my pleasure to invite Mr. Pasan Abeysekara to lead today's session. Mr. Pasan, the floor is yours.
Thank you. I think my screen share function haven't given it. Hello. 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 I think I have kind of shared the screen while someone is sharing the screen. Hello. Can you guys hear me? Hello.
Yes, we can hear you.
Sure. Uh, so good evening, everyone. Good afternoon, everyone. So in this session, we were going to discuss about the API security. So brief introduction to myself. My name is Pasan Silva, and I am final year computer engineering undergraduate and former software engineering intern at WSO2. And in this webinar, this is the outline that we are going to discuss. First, we will be now we are trying to understand about the API landscape and what is API means and all those basics that you need to understand. Then, before moving to the technical stuff, you need to have the critical understanding about what is the criticality of the API security and why API security is so important and such kind of bare minimum knowledge that you should have before moving into the technical stuff. And then you are going into the technical section. In this section, I'm going to first discuss about the API gateway pattern, and then I will discuss about the authentication, uh, and we will try to deep dive into it. So under the authentication, we will discuss first. There are five major authentication methods available and most frequently used. So we will discuss all those five methods within this webinar. The first one is basic authentication, and second one is OO 2.0, and third authentication method is OICDC, Open ID Connect, and fourth one is API key-based authentication, and the last one is mutual SSL DNS. And after that, we will discuss about the authorization strategies. So there are majorly two types of authorization strategies: role-based access control and policy-based access control. And then we will discuss about the rate limiting. And later part, we will discuss about the key API protection mechanism other than this authentication and authorization and rate limiting. And finally, we will try to understand about the OWASP top 10 API threats. And, and finally, we will discuss about the expected API security. That is about how to integrate dedicated IDPs. The IDP mean identity providers, and also how to get the use of AI for API security. And after delivering the key takeaways, you will be asked a Q&A session. So I recommend you to grab some notebook and pen, and at least try to write down the main concept that we are delivering within this session. So after this webinar is over, you can do your uh, own homework type of thing, like searching for those things and explore more. And also write down in the sections, you can have idea that where are you at that uh, given time, right? So take some screenshot of this, and let's see what we are going to do. The thing is, we will try to understand the API landscape. So the first thing is, what is API, right? And I may assume that you may already have already implemented the web application, some web application or mobile application. If not, uh, at least you may heard of the term called API. So the API means application programming interface. So this is by theory, this is known as a set of rules and specification that allow different software applications to communicate and exchange data. In the sense that we can understand, we can say that API is a messenger that deliver data upon users' request. So let's try to understand this concept clearly. So as you can see, here are the client section, and here are the server section. From API, what we do is we clients try to get some resources from servers. So this flow is go through API. So clients try to request some resources from servers. So this the request payload is somewhat representing the our API. So clients can have either web applications or mobile applications, or maybe the backend servers. Even there are backend to backend communications exist. So client can be this any type of thing. So for instance, consider example that web application is trying to access some resources from server. So this is the request payload of that. First, it is mentioning about the resource endpoint. Then it is mentioning about the HTTP method. Then it is mentioning about the include the request parameters, body, and headers. So server will receive this request payload, and first it is looking to what is the resource endpoint that he was requesting, and then he was see about his request headers and see if this client is permitted to receive these resources. If he is permitted, the operation is specified from this HTTP method, whether it is get, post, put, fetch, or delete. This operation will be done to this resource endpoint, and after the result will be given by JSON format or XML format. This format is specified in this request body. So this is the basically technically high level overview of how API is basically working. So this is the simple analogy that is too complex to understand the workflow of the API. So imagine if you are going into a restaurant and you are ordering some food. So in this situation, uh, imagine you are the customer, right? First, you have some menu. They give you menu, and you are ordering some food out of that menu. So then you tell that waiter, hey, I want this particular food, maybe a pizza. I want pizza. So the waiter will take your order and go into the kitchen and grab some pizza and serve that pizza to you. So same type of way you can use this analogy for APIs. When it comes to the APIs, the menu that the waiter is providing is actually the API specification. So you cannot ask anything other than this resources that are available in the API specification. So you are telling that I want this particular resource from server. So then the order pacing is corresponding to making a request. Then API will receive that request. Then kitchen is corresponding to server data. So the API will go into the kitchen, in this case, the server data, and then grab the data and then deliver that to the user by response. So I think this is more simpler analogy to understand other than the fully technical thing. And if you have never an experience about the APIs, this is the most popular analogy that used to understand the APIs. Then we will go to the critical understanding the critical role of API security. So far now we understand about why what is API, and now we want to understand why this API security matters, right? The topic of this webinar is not about API, but API security. So why this API security is important? The first thing is it can prevent data breaches. Uh, that means that it can reduce the risk of costly reputation damaging security incident. For example, there can be some endpoints that uh, exposing data that not supposed to expose. So that ultimately risking the privacy of the users of that particular company, as well as it is damaging to the reputation of the organization. So this preventing data breaches can uh, keep reputation of the organization. And the second one is maintaining system integrity. So this means that in simple word, hackers won't able to edit the data that is communicating through this API. So API is basically the communication between client and the server. So if you are keeping this API securely, this means that that data analogy, if you are keeping that data not replaceable, or you cannot change the food in between this kitchen to customer path, that means that that API has the system integrity, and you can sure that what you are receiving is what you are ordering, and nothing will be changed. So that is what one of the reasons that API security is matters. Another one is ensures business continuity. For example, uh, some organizations cannot afford downtimes. For example, maybe social media sites, maybe e-commerce sites, they cannot afford downtimes. Downtime means server is not working type of thing. If the API security has some concerns, in order to maintain that, system has to have downtimes. In that small downtown, there can be so many uh, money costly thing to of the organization. So if you plan in the your design your API in a secure, more secure manner, you can prevent those downtimes. There can be ton of API security important things that list down here, but these things is enough to understand the criticality of the API security. And next thing, confronting secure challenges of API. So these are some high-profile data breaches examples that explain the importance of API vulnerability. The first one is LinkedIn. In LinkedIn, in the past, there were some lack of because of the lack of authentication in LinkedIn. 92% of users' personal data was exposed to public. So that was because of the poor planning in the API. And another famous one is this Just Dial service has unprotected public endpoint that exposing personal data of uh, each person. For if you zoom out this, I think you can see this. So when I zoom out, right? Uh, so as you can see, there are personal data is uh, given as response for this public endpoint. Someone's first name, last name, full name, birthday, city, mobile, image, privacy, all those things. Those are not the things that supposed to put on public, right? This is also example of poor designing of API as well as the lack of uh, API security. So then we will go into the technical section. In this section, you have to have maybe some little understanding about the sofa that we have discussed. And I recommend you to take paper and pen and at least write down the each what each sections is explained, right? You don't have enough time to write the whole the content, but you can later search for this by your own and have much clear and crystal understanding about this area. So the core areas of API security consideration. So first thing is we will discuss about the what is API gateway pattern. Uh, so maybe you guys are heard of a, microservices, right? Uh, I think even if you don't implement a microservice, maybe you guys have heard it. In microservice, there are multiple APIs in particular in one microservice project. Maybe 5, 10, 50, maybe those time amount of APIs is existing. So it is not a smart move to implement the same API security logic in all the microservices because of mainly two reasons. First thing is that is redundant. You implement the same thing in same uh, or every microservice. It is time consuming. And other thing is you may not implement same and consistent securities among all the microservices. So in that for that reason, we usually implement microservices in the API gateway. So first, the problem that we have is we have to address the API security. Implementing in each API is complex and inconsistent. So solution is offload security responsibilities into API gateway. So let's is in brief explanation about API security. Uh, so this is the clients, right? This is a very simple and high level overview. Therefore, you can go into this API gateway and you can see so many advanced concepts behind this. But in high level overview, this is the thing happening in here. There are clients here and there are the microservices. This contain of orchestration. These microservices are connected into the data source. As clients, we don't directly contact this to each of these microservices. We communicate to these microservices via API gateway. So all the traffic is go through this API gateway, right? So in order to implement API security, we can implement it in here, right? So if there are common API security principles are going to apply, we can implement that in API gateway. So it will be affected to all the microservices in here. So the benefit, so the API gateway decides between API backend and consumer clients. So this is the API backend actually microservices. So this is the clients. So what are the benefits? Developer focus on the business logic and consistent security enforcement, and also extendable security capabilities. Because, for example, there can be some security enhancement that you may want to do for the project. If we are going to implement the Microsoft API security in each of these each project, that you have to update the whole projects one by one. But in this case, if you implement this API security in API gateway, you just have to uh, make that improvement in API gateway and it will be affected to all. This is also another uh, benefit of using API gateway pattern. Then this is another crucial concept that you need to understand. Please listen to this carefully and try to understand this concept, because this core concept is the one we're going to discuss in maybe another 30 minutes or something. This is API risk control. This is actually foundation of API security. So there are two pillars, right? Authentication and authorization. You may heard of these terms before. What is the authentication and authorization? And uh, you may be confused between what is the meaning of each of these and is this the same thing? And but I mean, you maybe struggle to understand the distinguish between these two concepts. In this is very simple concept. If you say that authentication is something about who you are, authorization is something about what you can do. So you can say there are many interpretations for this, but its basic idea is this one. In the API context, what we can say that from authentication, it will be tell who can access which API, and authorization will say what functions can they consume. But if I say it that directly, you may still have struggle to understand what that each meaning. I will tell you some example and try to understand from that. For example, uh, imagine a student management system or maybe university management system or something. Student management system, there is a API service. Imagine a microservice based project about student management system. Inside the API gateway, so in the previously we discussed about this, there are several microservices in this container orchestration. Imagine there is a particular microservice called exam, right? So this exam, so maybe for exam, so in this exam endpoint can be accessed by both students and teachers, right? Student can face to exam, teachers can create exam. Uh, so here the question one is who can access which API. So if we consider about two roles for student and teacher, they both can access uh, exam API. But inside the exam API, there maybe have a resource function for creating exams. So there is a API for exams. Inside that API exam API, there is a resource function for creating exams. So the creating exams is only capable for teachers, right? Student cannot create exams. So in that case, both student and teachers can access the API, but only teacher can uh, consume the function of exam creation. And as you understand, that is the practical difference between uh, it is authentication and authorization. So if both of these guys are signing into the application, they are telling that they both belong to the education domain, right? That's why they both have access to the exam API. For example, if there is something called uh, non like PN or something, if they cannot access to this main exam API, right? Only student and teachers. So that is some practical example to understand the difference between authentication and authorization. So I hope you have some understanding. If it is not, please take some screenshot and maybe put into Google or something and try to understand within this next minute or something, because from now onwards we are discussing about this authentication and authorization in deep dive. Uh, I think it is uh, okay. Then I will move into the authentication, right? First thing, authentication. So basically, authentication is about verifying identity. Before I move into that, I could ask you that whether you got understand. Is there anything to ask about so far? Can you please put the thumbs up or something? At least you understand about the authorization and authentication, because next part is completely about authentication and authorization. Yeah, at least you can distinguish between those two things is enough. Do I need to re-explain the authentication and authorization, or should I continue that? Anyone can put some message or maybe okay, continue. Thank you. Thank you for response. Then we go into the authentication. So this authentication is mostly about verifying the identity. So how can we verify our identity is basically about from these three things. We can verify our identity from something you know, maybe password, or maybe something you have, like token. In the API context, this thing is not using card or fingerprint. Uh, Token is the one that you're using, or maybe a combination of both of these things, password and token. That is called multi-factor authentication. Uh, so previously we have discussed about what is authentication mean. Authentication means identify who you are. So this is verifying your identity. These are the methods that you can combine to verify your identity. Then we will be discussed in the few sections about what are the common methods to for identify for authentication. Uh, Password based, token based, certificate based. These are the categories. Actually, there are five methods. These are the categories that they are divided into three, but there are five methods. Before moving into the authentication methods, you should have understanding about what is API headers and HTTP headers. Uh, so that's why I'm adding this section. So API headers can be divided into these categories: request headers, response headers, general headers, and entity headers. But in this section, we just only need to focus on request headers and response headers. Mostly only the request headers. In request header, you need to in this future slide, you need to consider the value of this authorization header value. Uh, Again, I'm saying in this future slides, you are going to use these request headers. In this request headers, authorization header value is the one that you will be using to pass the tokens, right? So have some understanding about that. You are using request headers or the authorization header. So this is the first method, first authentication method. I told you there are five authentication methods. This is the first one, basic authentication. Uh, so here, this is the basic authentication, most basic authentication and simple authentication method. And this is not really used in any public or sensitive APIs because of the simplicity and vulnerability to share sensitive data like your username and password. I will tell you why. In this method, first you can see that client is putting some GET request to the server, right? There's a HTTP method and there's a uh, resource function that you want to access. But you haven't specified any headers, authorization header or anything. You just say that I want get method of this form resource. So server will tell you that 401 unauthorized status with saying that you don't have access to this. That's because in the basic authentication, uh, you need to pass authorization header. I have discussed what is authorization header. It is part of the request header value. You need to pass authorization header with basic keyword in front of it, and the value should be this one: username colon password base 64 value. I think you get that. This YWXP, the weird string is this client's username colon password base 64 value. You can see how to convert a string into base 64 value by just Google base 64 converter. Then you will see that you can convert a string into this base 64 format. Uh, so what is the so the thing happening in here is the server will receive this resource function and method and authorization basic header and see this value. Then it will be decode this into username and password and see that in the lookup table. Lookup table is something like database and see that whether this client is registered under this server. If it is, it will be give 200 status. This means okay and give a successful response. So client will have its requested response. So that is the whole logic behind this basic authentication. So why this is not using in anywhere? Because as you see with the request, we are passing our username and password base 64 format. Anyone can access this. Anyone can access this and decode it and see what is your username and password. So there's no security at all. This is the most basic authentication method. Later we will tell you what are the proper authentication methods that use. Right. So I will be moving to the next method. Next method is the most frequently used and almost anyone using method. It's called all 2.0. So in here, key principle is that we are not sharing username and password directly with the client app. Instead, we are using something called access token. So this access token has a limited lifetime. And also it is application specific, reduces the risk of token theft. That means that imagine that this access token is stolen or something. If even it is stolen, it has no value because it is already expired. No one can use it. But in the previous case, username colon password base 64 can be decoded into the any time and user can use that. A hacker can use that to username and pass to identify username and password. That is not changing anywhere. But this thing has a lifetime. So it will be expired. Then, but there are four roles in O 2.0 that you have to have an remember. I mean, you have to know these things because future we will be mostly discuss these things. Resource owner. This is the actually a user. Resource server is the API backend, client application, and authorization server. So new thing is there is something called authorization server. In previous slide, you can see that there's only client and server. There's no authorization server or something like that. But in here, there's an authorization server. This is due to this is the server that issuing the access tokens. So let's go into how these tokens are obtained. So as you can see, under the OAuth 2.0 authorization method. So this is the second method that we are discussing. There are mainly six common grant types, right? Uh, these six grant types will be used under OAuth 2.0. These six grant types have their different purposes. We use this to our particular purpose based on based on our purposes. We will use this. So first we will discuss all those things. First, we will maybe you take a screenshot of this, then you have understanding in the future slides where you are at right now, right? Maybe you can Google these things separately and have better understanding later after this webinar, right? The first thing is we are going to discuss about this authorization code. As you can see, it is very easy to understand this whole thing. Rather than looking at this diagram, imagine I have some real life example. Imagine you have downloaded the photo editing application, and that photo editing application, you need to have access to images. For example, you need to have access to Google storage, your Google storage. In that case, so in this particular example, this application client is that downloaded photo editing app. This user agent web browser is your mobile app's default browser. Maybe Safari, maybe Google Chrome, or anything the default browser that you will be redirected to. This a port server service API is really the Google Storage API. So resource owner is you. So when you download that photo editing application, it will from the application's UI itself will get show you a prompt asking, hey, I want to access your Google storage in the application UI, right? Then you say, yes, I want to grant you from the application UI. Then you will be directed to your uh, mobile applications browsers from your mobile applications default browser will prompt a Google prompt, right? Asking whether hey, this particular mobile photo editing application asks me it want to access your Google photos. Should I grant it? Uh, I think guys already experienced this experience, so you can. So the first thing is in the application UI itself asking your uh, permission to access these Google Photos. That is corresponding to this first arrow. It will be direct. It will be making a user authorization request via your browser. So this request will be sent to the authorization server Google storage, not directly from your app, right? Understand that it will be making through that browser. You don't need to uh, put in yes to receive this send this request user authorization request. If you press yes, it will be corresponding to this second one. You authorize application to access your photos. First one is just asking Google storage hey, I want to access, hey, I am a photo editing application. I want to access this client's uh, photo, Google Photos, right? This is the meaning of the first request. The second one is the user accepting, user just saying, yes, I am permitted to this applications to access my Google Photos. So after 1 and 2 both receives, auth server will issue a authorization code grant. So this authorization code is not the access token. It is just a temporary one-time use code. Then see clearly see this. This arrow is go through your user agent browser, right? This arrow will go through your user agent. That means that authorization code not directly sent to the your photo editing app. It will send to that your browser. Then that browser will send that one-time authorization code to your photo editing app. Then that so that in this stage, photo editing app has received Google's one-time authorization code. This is actually short-lived one-time authorization code. Uh, then in this fourth step, this authorization code, uh, along with client ID and client secret, will make a request to authorization server to asking access token. As previously discussed in the web OAuth 2.0 introduction, I told that speciality of OAuth 2.0 is not using user name and password for the client application. Instead, it is use access tokens, right? So that is what happening in this fifth step. This fourth step will ask in access token. This fourth step, in order to ask a request for an access token, it should have authorization code as well as client ID and client secret. So the client ID and client secret is already in your browser, right? Uh, your photo editing app has access to that. So far, it haven't got any authorization code. After receiving that, it got this all three things in their pocket. So the stars are like it will make the access of token request. Then it will receive the access token. So after your photo application receives the access token, that means game is over. They can uh, they can continuously access your Google Photos with your each API request. So that is the whole flow of this authorization code. And I think you understand that. I don't have actually enough time to repeat that same thing because there are any other four methods we need to discuss, right? Take some screenshot if you want, then you can later uh, go through this way. Second method is password grant. So in here, in the previous one is actually the most commonly used authorization method. As you can see in the description, most common and a secure method for web and mobile apps is the authorization code method. So now I'm explaining the password grant method. This is not actually the most secure way, and this is not actually used in any third-party applications because in the previous one you never seen any credentials is sharing between any edges, right? But in here your resource owners password credentials will be shared. In the previously authorization code ones, it is not sharing. This password grant is only used for first party application. By first party application, it means the applications created by the service providers. So for example, we are talking about this Google authentication, right? So there can be Gmail application. There can be Google Meet Gmail application and maybe Google Drive application. So these apps can be considered as a first party application because they are give made by the service provider itself. Between these things and authorization server, they have this password grant type credentials. You are in practically, you never use your Google account's username and password in any third-party application. You just make use that in your Gmail application. So in here, resource owner will put your password and username. Then authorization will receive this password and username. It will look into a lookup table and see this is a legit, already registered user in its own database, and then it is permitted grant access token. Then using this access token, resources can this client can receive resources from resource server. This is actually very simple than authorization code that we code grant type that we previously described. But in here, only catch is that even this is simple one, this is not a secure way because we are sharing passwords, right? This is more like our very initially discussed uh, basic authentication method. But the only thing is we are using access token here. We are sending our username and password with client ID and client secret. Then we will receive back the access token, and we only use that access token to the resource server. Even in here, we are not sharing password with resource servers, right? We are only share a password with authorization server. That means Google API. Uh, I think you have some understanding about this password grant type. Then I will be moving to the next grant method. This is the client credentials method. So this client credentials method is the client credentials grant type method. This is mainly to communicate between backends. For example, uh, most of the times that application API is used by real user, right? But sometimes backend to backend communication is also happening. I will tell you some example. Imagine our university has some a university management system. Imagine that is a microservice project. So there's a API called exam is exist. There's a API called exam, and there's another API is called admin. So in order to schedule an exam, you need exam need to have understanding about what are when is the gym is available, right? In order to conduct our exams. But our exam API don't have direct access to those information about which physical uh, which buildings are free at which time. So in order to know that time, our exam API need to call to admin API. So in this example, our client is exam API and resource server is admin API. I mean talking about our university management system like hypothetical situation. Uh, so there is no any client actually, real person client, but the client is our exam API. Since we have no any password or username, here we are using client credentials, which means client ID and client secret to send it to the authorization server and receive back a authentic or access token. So using that access token, like in previous times, we are using this access token to authorization header. I think you remember what is authorization header means. Authorization header is request headers part of the value. So we are putting this access token in authorization header. Keep in mind that we are in front of that access token, we are putting some keyword called bearer, B-E-A-R-E. That's the keyword that we put in front of this access token in authorization header. So this is how backend to backend communication is happening. And next one is K-Pros grant type. This K-Pros grant type is not actually very commonly used at all. This is only used in corporate networks. For example, what is in here? This is the client. and client will first send a request called client login to authorization server. Then client server will send back a TGT. TGT means ticket grant ticket. So this ticket grant ticket will be received to the client. Then using the ticket grant ticket, this client can send to the ticket granting server and receive another ticket. This is actually ticket lockup. I mean ticket. So in the when here after TGT received ticket, it will be sent to the ticket granting server. So we are telling that ticket granting server, hey, I need to have access to another computer in our corporate network, another computer or another server in our corporate network. We are specifying what particular uh, network that we need to access in here. According to that, in this four step with TGT, we are mentioning what particular network that we need to server that we need to access within our network, and TGS ticket granting server will send back a client to server ticket. That means that we are saying that we need to access to server called A. Then with the TGT, we are saying that we want to access server A, and this will issue a ticket only to access server A. So using that server A ticket, you you can have access to that server A. Then client to server communication is happen through this client server ticket. So this client server ticket is also encrypted. One like previously discussed access tokens. So this is the concept behind this KPROS grant type. This is actually not very used at all. This is only used in corporate network like Windows Active Directory. Next one is most very common one. Very common one is that this is actually used in previously mentioned access grant type as well as sorry, we previously mentioned authorization code grant type. We using this as the next step. In the authorization code grant type method, we stop all the process by saying this one. I will go back to that. In here, we are stopped by this step, right? Application client received the access token, but we haven't said anything after that. What this client will do with this access token, we never said anything about that. So that part is belong to here. This refresh grant type. So in here, the client will authorize authorization grant make a authorization grant to the authorization server, and client will receive access token and refresh token. So I haven't tell anything about the refresh token and access token. What is that meaning by each of these things, right? So access token has expiration time usually to like 1 minute, 2 minutes, maybe 5 minutes, like very short times. But for the refresh token, its expiration time may be 1 month, 3 months, maybe half a year. Like it has uh, long expiration time than access token. So the first thing is that, as I mentioned, discussed in authorization code method, client will receive an access token with refresh token. Then client will make a call to the resource server with its requested resource endpoint with this access token. Hey, I need this resource because I had this access token. Then you need to grant me the resource because the requirement of the requesting resource from the resource server is now having a validate access token, right? Having non-expired access. If you have a non-expired access token, that means you can access resources from resource server. This is what is C meaning. C is saying that with that access token, call into the resource server and getting the resources that are needed. In the E step, when it comes to E step, uh, there may be the time that access token is expired, right? Access token, I have told that it has short-term expiration, like 1 minute. So in the E step, it is already expired. After resource server receive this expired access token, it won't give you the resources as requested. It will tell you that invalid token and error. So in that place, client don't need to do the whole the previous thing again because it has already access to the refresh token. So the client what will do is it will call. Okay, uh, can you listen to me? You can see me, right? Uh, okay. Okay, I hope you can see me. Uh, okay. So in here, after access token is expired, refresh token will be sent it to the authorization server, and it will be asking a new access token. So client will have this new access token now. That's the whole the logic behind this refresh grant type method. This server gives the app temporarily hold pass, and the refresh token is a renewal slip. Like this access token is the temporary path that have given to you, and refresh token is the renewal slip that you can get a new hold pass after hold pass is expired. So that's the renewal period. And then we goes to the last of the O 2.0 authorization method, JWT grant type. So in the JWT grant type, as you can see, uh, a client exchanges cryptographically signed JSON web token with authorization server to obtain an O 2.0 access token. Uh, can you hear me? Is my screen is freezes? Give me a minute. I will. Okay, so for the please interrupt. So as you can see, this is the JWT grant type. Here user here as you can see, user is signed into the authorization server and user authenticated JWT will be created, and then JWT will be passed into the application server. Then application verifies the process of API call. So here authorization server's public key ensure JWT haven't been tempered and was indeed issued by a trusted authentication server. Uh, Now you can see. It's, sorry for the inconvenience. Internet is corrupted. Internet is interrupted. Sorry. So authentication server's public key ensures the JWT haven't been tampered with and was indeed issued by a trusted authentication server. And JWT obtained a step to act as a primary token for accessing the application server. So then I will be going to the third method because we take too much time on the 2.0. In note, authentication method 3, we are talking about the OpenID Connect. So here, this OIDC, also known as OpenID Connect, is built top of 4.2 or 2.0. All the concepts in the 2.0 is applied same in here. But only difference is we add the additional identity layer in here. We will discuss what is mean by this. I think you guys have already experienced the SSO, right? Single sign authentication. So this is the logic behind the single sign authentication. SSO. SSO means that if you know, didn't know, don't know, it is already that when you are signing into the new website, it is asking about that you don't need to enter the password. You can sign in via Google or GitHub. That you can link your credentials of your Google account to the new registration of that web application or any mobile application. So that is called SSO. So this is the logic behind it. So this OpenID Connect is basically consisting three phases in here. The first one is user authentication and getting authorization code, and second one is this received code exchange with token. Third one is using these tokens. If you haven't cleared it already, just read these three phases. First one is use authentication and getting authorization code, as we discussed in our 2.0's first method authorization code. So the second step is exchange this code for token, and third one is abuses the tokens. So in here, uh, so the user agent will asking for this open IDE provider is like Google or Okta. Uh, there are many competitors for that. Most of the company use open ID providers like Google and Okta. So first thing is this A represented by uh, user agent or user will ask for uh, will deliver its client ID and client secret, and then it will be get back with authorization code as we discussed in O 2.0. Then using that authorization code, user will directly call into the open ID provider. So here see that this first flow is involving with browser, but this one is we are calling back channel. Uh, that is that application in the first place connecting to the OpenID provider via browser. But in next stage, after receiving the authorization code, it will be directly calling to the OpenID provider, and it will be receiving access token and ID token. So in OID OpenID Connect, only difference between O 2.0 is receiving this something called ID token. So this ID token is a JSON, JWT token, JSON web token that contain authenticated information about end user. That means it has user ID, email, that when they are logged in, type of information. So this is the core idea of OpenID. Uh, that the piece for proving identity. So this is the thing that we used in SSO for its thing. For example, in this H request that calling for user info for obtaining to relevant claims. Imagine that if you are logging to the new website through this SSO, but it is not have but within this ID token not have your profile picture and full name. In that case, since your application has already received this access token, you can call to this OpenID provider and asking for your Google's profile picture. So if your ID token already has that data, your relying party other known as application don't have to call to this OpenID provider. You only need to call this OpenID provider if that data is not available in ID token. So these ID tokens and access tokens, these all are JWT tokens, right? I hope you already have understanding about what is JWT token and you ever tried this one. If not, please Google JWT token even right now. It is fine. Then you will see that if you go into jwt.io, there are some uh, lengthy string, and the right side there's the decoded one. I think I have mentioned in later slide what is example of decoded JWT token. But for now, this ID token can contains many information regarding to that user identity like name, location, and so many things. If the information that is not included in ID token, you can still access from OpenID provider because you are having this access token. That is what the meaning of this H request. So the whole OpenID thing is basically same as OP 2.0's authorization grant type. Only additional thing is ID token is input. So you have the understanding about application has the understanding about users personal data uh, like email, user ID, and those type of things. I hope you have basic understanding about that. Maybe you can study about this more from your own. But the basic understanding is it is exactly same as O 2.0. Only difference is it is having identity layer and it is involving in ID token. So here access token that can use as protected resource behalf of the user. There's next one. So far we have discussed three authentication methods, right? First one is basic authentication. Second one is O 2.0. Under O 2.0, we have discussed five more brand types. And third one, we have discussed authentication methods as uh, this one, OpenID. And here comes the authentication method for API key-based authentication. So in here, uh, this is actually simple form of application based on security. Uh, this is actually very simple compared to the previous one. This is using API key for its header, not using any authorization headers. In previous O 2.0 and basic authentication, we have discussed that it is using request headers, uh, authorization header. In here, we are not using authorization header. We are using property called API key. And this API key value is not any base 64 value or any JWT token value or anything. This is some numerical unique value, and this will be with after server receiving this API key, it will be look into the lookup table and see if this person has access to this API and then give the response. For example, imagine about that the OpenAI API, Gemini API. So all those things you guys have this open key or API keys, right? So imagine person you and your friend both has two different API keys, but you both privilege the same thing, right? maybe you both pay for the OpenAI, but you guys receive the same service from them. That's because you, you both receive the API keys, and when you make your request, it will be look up into the lookup table, and both of your API keys are in that database. That's why you have given back the same uh, service from OpenAI servers. So this is the simple thing that is behind the API key based authentication. This is very simple compared to the previously explained authorization code like type like authentication methods. And other one is last one, actually authentication methods last one. This is a mutual SSL and TLS. So here this one is actually certificate-based authentication, not token-based one, or not any numerical API key or anything. This is actually certificate-based one. This will be used in very sensitive and B2 applications like B2B integrations, and there is two-way authentication. So this is the flow of all those things happening. The first client will request the protected service request from server. Then the server will provide the certificate. Client will ask for service certificate. Server will provide the server certificate. Just look at this word here. Service certificate is requested and service certificate is granted. Using the server certificate, client can access the client will put into the certificate authority, and then providing the client certificate, server can verify the client certificate. Then after verifying the both server certificate and client certificate, protected service executed. So this is it signed by this in this first verification. Verify server certificate is it involves that it is checking that is it signed by certificate authority, is it signed by a certificate authority the client trusts. That is what is my validating means. The verifying certificate server certificate meaning it is checking is this signed by a certificate authority that the client trusts. Then other than this is the is it still valid? Is this certificate is still valid? And other thing is, does the name on the certification match with the server it is trying to connect to? So these are the things that is checking before it is accessing to the server. So this MLTS add the extra layer of the security by requiring both client and server to prove identities using digital certificate issued by trusted authorities. So this is the most protected authorization authentication method out of all those things, because both client and server need to verify their digital certificate in order to communicate with each other. Please take some screenshot or maybe some note, and you can dive deeper and have crystal clear idea about this, right? For now, just understand this is the most protected one and used in sensitive applications like B2B integration. Okay. So far we discussed about authentication. Now we are going to discuss about authorization. So let me recap this one. Authentication. This is what we have already discussed. We have already determined that who you are. Now we are going to determine. We know who you are now. We know that we are student. The server know that we are student or teacher. But only thing that we don't know yet is each resource function is permitted to our role. That is what we are going to understand in this authorization. So there are two methods for authorization. First one is role-based access control. This is the very and most common one and practically used one. So this is commonly implemented with over 2.0 scopes and grant permissions based on consumer roles. For example, so this is an example that is provided. There's an API called shopping cart, and there's a resource called items. And this shopping cart API can be accessed by both employee and manager. That means uh, from they are both authenticated. That means that manager and employee both are authenticated to shopping cart API. That's why they both have access to this. But distinguish their permissions for accessing that resources because their authorization is different. This man has role as a manager and this man has role as an employee. So since their roles are different, even they both have access to this resource function. Operations is different. So that is what authorization is due to you. I think I'm clear. This is not any complicated than that. So this is basically so this is how so this is the JWT token. So example JWT token, how it is decoded after that representation. If you go into the jwt.io, you can test this out. So this is a sample JWT token for access token. This is actually sample access token. You can see there are roles in here, user and editor. If the user is login to mean authenticating to some server, they will be issue access token as we previously discussed this on 2.0. But inside this access token, this role can be different. In this case, this man has the role of manager and this man has role of employee. That is different, distinguished by this property, these roles here. So this is the uh, thing that differentiate what resource functions can access by each user. So if for the previous example for role-based access, this is the simplified table version. API is shopping cart API, resource is items, and these are the actions, and these are the each actions permitted roles. Put request can be only by manager, get can be accessed by both you guys, and post can be accessed by manager. The other authorization method is policy-based access control. This is not that much used as previously discussed role-based access control, but uh, is somewhat used to here separate your application's business logic from authorization logic. So the previous only the reason to having this policy-based access control other than role-based access control is you can divide your business logic uh, far better in policy-based access control. For example, in previous example, we said that role is different for particular users, right? That role difference is made on the code itself. So you are written code for this API endpoints, and you are mentioning this role is dedicated for this resource function is only dedicated and only permitted for these particular roles. You are writing code in you are mentioned this in your code, but in policy-based access control, you can separate your code and logic at authorization logic far better. For example, there may be an instance that only managers can open this door after 5 p.m. like something. So there can be a company that door is automated, and this door can be only opened by managers, and also it should be open by managers after 5 p.m. So this kind of policies can be separately applied when we use this policy-based access control. So the flow is right. This is the application. You can consider this as your user. And this policy enforce point, PEP, this is not actually the brain of the system. This is just the checkpoint. This is just asking that can this application perform this action on the resource under these conditions, type of thing. So the PDP is the brain of the policies. That means it has access to this policy repository and it will be checked into the policies and determining whether this thing is permitted or not. Then the PIP, this policy information point, this connect to the various databases like LDAP directories, and it will give you some descriptive attribute. So, so basically, from policy-based access control, you can have far better business logic separation with your authorization logic. Then all the authorization and authentication, both of these has been discussed now. Now we need to discuss about the rate limiting. So the rate limiting is, you may heard this term, right? When I think you have experience in using some public API like OpenAI, or Gemini API, then you see that there are some term called rate limiting. So rate limiting is, as the word means, they are limiting some rate to access that API. That means that this limitation can be made by number of requests or bandwidth or query complexity. They are making this rate limit to actually limit the access to these resources. So there are few benefits by doing this. First one is it can prevent DDoS attack. If you don't know about DDoS attack means you are putting a flood of internet traffic to compromise computer system, so making it unavailable to legitimate users. For example, very practical example is that we all having quizzes in our campus, so LMS, right? If there are 200 or 275 students log into the system, no one can, even legitimate candidate cannot enter to the system. We can also fake the situation if there are like 25 students or something. We can also fake the situation by uh, uh, putting fake traffic into the system. But in that case, so imagine that there are 25 students only available and we only need to postpone the quiz or something. We can add some fake traffic into that because that LMS API don't have rate limiting, implemented rate limiting. In that case, we can add more traffic to make this like LMS not working and postpone the lecture or something. I mean, that is some practical application of this rate limiting not even implementation. If the rate limiting is implemented, uh, there's actually maximum limit that server can be accessed. And the other thing is implementing API usage plans. So this making APIs is some kind of business, right? Uh, I mean, if you guys into crypto or something or anything that you may need to access some crypto dashboards. So if you're going to use the UI, you can see all those things. But imagine that you need to get all this. No need to crypto actually. Just imagine Twitter. You need to have. You need to use Twitter API to get the trending APIs, trending Twitters. So if you go into the plan of the Twitter, there can be plans like basic plan, pro plan, and premium plan, like of different plans. So each plan has different rate limits. So the more money you pay, more rate limit is more less rate limit is provided to you. You can access more requests at limited at a given time. So by implementing rate limiting, you can implement this API usage plan as well as a business. Uh, Also, the enforces the AI usage policies and protect system from overuse and request spike. That is about the rate limiting at Maxwell. Let's talk about the API protection. Use this access control. So I think you guys have already experienced may at least making some React app, right? Then you will be experiencing the situation that uh, I have created the React app, but when I connect that to the backend server, it is not fetching. It is giving cause errors. So why is that? Reason is that in your browser, uh, that you imagine that your React app is working on local host 4000, right? But your backend is working running on localhost 3000 because two different ports need to be run simultaneously in order to run both of these at the same time. In the React application, for the source, I mean, for the source address, you have that uh, localhost 3000. Even the your React app is working on localhost 4000. But those data will not be retrieved to your React application because from the browser, it will be, in the browser, it has a security mechanism that is restricted cross-origin FTP request. This cross-origin means two different origins data cannot be transferred. It will be blocked. That is basically uh, basic meaning of this core mechanism. So what you can do is you need to manually permit that hey, I need to only accept. You need to permit only request from this particular port. In the React app, you have to mention that I need to accept request from only port 2000. Other one you can restrict, but only permit port 3000. So you have to enable CORS for that particular port in your both front end and back end. So that is some practical experience that you have may experience regarding this course, and it is also API security strategy. So this is a practical example that I have talked. So this is a website called a.com, and this is the web server a.com, and this is a web server from same domain a.com. So this image is retrieved, right? And that is why this orange color. Uh, this image is retrieved because the same origin request is always allowed. But in here, uh, even this is website is called a.com. This website is from b.com. From a.com, it cannot request any resources from b.com because cross-origin request is controlled by CORS. It is blocked. So this image is not rendered. I think you get the idea. So that is the API, one of the API security methods that beyond access control. The second one that we are discussing is bot detection. This one is also you have experience. That's captcha one. So in if we put that bot detections, you can prevent this open port scanning and also automated attack from credential stuffing. This open port scanning is basically go through all the open port in the domain and try to add some unlimited loading to that request that endpoint. So by using captcha, you can prevent this open port scanning, and also it, this bot detection. You have another advantage. You may know about web scraping, right? I think. Do you know about web scraping? If you don't know, just Google it. Then you have idea what is web scraping mean. Web scraping is uh, you are getting when you are going to some website, you can crawl all the things as HTML and save it into your local machine. Practical application of uh, web scraping is something like you have heard of this Twitter, right? Twitter API is very expensive, like over $100 or something, even the basic plan. So even so, but there are some applications that may need to have the need to get the Twitters. In that case, what we and I personally do is we get the URL, that specific Twitter feed URL, and save it in the RSS feed or something, and then scrape the whole the thing as HTML. Then we targeting each targeted views and list down the Twitters. So by the end of the day, we can we can create a custom uh, Twitter API that is not the official API, but we are just getting the Twitters from web scraping, just fetching the HTMLs from the web, then filtering out the other things, only keeping the required things and well formatted as we required, and for uh, and then we can use it as some unofficial with API. But the thing is, they have implemented this captchas so that they are asking what whether you are a bot or not. So these automated things cannot be do when this bot detection is done. So sometimes this web scraping is failed, and we cannot keep that into automation because in the middle of the nowhere, all the things is interrupted and ruined because they are asking randomly, are you a bot or not? Sometimes we can bypass that, but we cannot sure about it. So that is why they implement these captchas. And this is the example of bot detection, that is another API security mechanism. And another one is malicious payload. In here, we are putting that like in the API call for the payload, we can put some malicious thing so we can affect to that server. For example, if you ever heard of SQL injection attack, that means that in the payload we are putting some malicious SQL code that can ruin your the application server. In the same way, the cross-site scripting is putting in your payload adding some malicious JavaScript code. In the same way that DDoS attack is putting some regex, malicious regex expressions in the payload. So when you are designing an application for a commercial use, you need to think about these facts, right? You need to consider that whether this payload, this our created API is can handle these type of attacks, and whether these attacks can be prevented. And maybe you have to consider these as edge cases and try to escape these things. Maybe put some exceptions if these type of things have occurred, and like custom exceptions have to be implemented in order to avoid these kind of situations. So this is another thing. Other thing is data masking. If you ever work on some uh, crucial, I mean, privacy-based application, personally I have worked on during my internship on banking application. So there are bank our payload is mostly containing bank account details, right? So there are bank account number and like so many sensitive data. So we need to make sure this bank account number like things are masked. You need to ensure these things are masked. So between communication of the server and client after is without masking. If we didn't mask these things, anyone can see. what is the bank account of this particular individual, right? And also, other than the masking, we need to uh, as much as we need to try to not to use the personal details of each person. For example, in this third one, you can see that return is over 18 true instead of actual birthday. Some application you don't need to actually put that man's birthday because someone can do some social engineering shit and gets this password or something. So you need to make sure that try to prevent to uh, add that type of personal details into your application and try to convert these to like this kind of binary things is over 18 is actually enough. No need to have his birthday and then recalculate it whether he's 18 over 18 or not. I think that is then we go into the fraud detection. This fraud detection is actually uh, related to anomaly detection. So if some API has some anomalies, that means that we can implement some AI and machine learning concept to identify different anomalies in and no abnormal behaviors in traffic. So the traffic is basically gathered by the logs in the API gateway. So I have told you that the API gateway implemented in security is API security is mainly implemented in API gateway. So we can read those logs, and one thing is we can read those logs and manually see that what are the anomalies. But that is not practical, right? But we can train some AI machine learning model to identify suspicious and abnormal anomalies. Then we can also see some unusual geolocations and rapid requests from new APIs, and we can we can detect some abnormal access patterns. After that, we can maybe blacklist them and prevent those end users to access our APIs further, so that there's a potential that they are doing harm to our API. So this is the uh, high level overview of what is fraud detection mean. Then we goes to OWASP top 10 security threats. This is actually the industry standard for API security that considering these top 10 threats as you should make sure that your API is satisfying and satisfying, not satisfying. Actually, our API is capable to prevent these 10 API security threats. Uh, since there's lack of time, I will not go into this top 10 API threats one by one, but you can, of course, definitely Google that OWSP top 10 API threats and look into this one by one. This broken left Bola and broken authentication is very popular API threats. At least look into those two things: broken object level authentication and broken authentication. And other thing is security by design. And so it means that Open API specification, you may heard of this or not. This Open API specification is the industrial standard and language format for describing HTTP APIs. So, for example, so this is the example for this is I have got this from official Open API specification. This is not Open AI, right? Open API. From example, below is the below screenshot I have got from Open API official documentation. This is the example of below showing properties for client credentials and authorization grant types. So as you can see here, this is a YAML file. You may know YAML file, right? WAML file type. It is just a way of structuring your things by putting tabs in front of each levels. So number of tabs meaning separate the levels of the file, right? So as you can see, these are the flows for client credentials, and these are the flows for authorization code. So you should follow this industrial standard language format for describing HTTP APIs. So there are tools that automate tools that can uh, scan the definitions and find the common security flaws. If they identify any security flaws, it should be definitely fixed before uh, put into the production. So from my experience, they are before put into the production, they are doing some security review, and they are checking this open API specification and all those things, and give you back a report, and you need to pass that to put to your application before put it into the production. Uh, so then just go through them more about this open API specification. You will find out more about this. And the next one is dynamic control policy management. So this dynamic control and policy management thing is actually API was security needs change. So this is the so as you can see, API gate. So this is the communication between client and backend API. So the client request is in the handlers. This is contained in the API client ID and client secret, and then it will be going to this request sequence policies. In this request sequence policies, these things can these policies are checked: authentication, authorization, rate limiting, and request transformation and input validation. In the other way around, after API backend, we send back you the resources to this handler, and the response also checking these response sequence policies for response transformation, caching, logging, and adding headers. In this whole sequence policies, it will be checked into the any of the missing and not satisfied policies, and uh, check those fault before uh, accessing, before putting the request to the next request code and next API code. So this whole sequence policies is make sure these request sequence policies and response sequence policies are both are satisfied. Uh, so this is a special section that use extended API security, and the last sections of this session. So you may heard of this identity providers, right? Uh, if you ever read some application in React or something for your university project, you may heard of this Auth0. This Auth0, using this identity, you may never implement this previously mentioned authorization code or 2.0 authorization code grant type, password grant type. These things you may not even implemented by yourself, because these identity providers are implemented by themselves and provide. You just need to plug those things into your application. So that is what these identity providers are do. So they are providing authorization, authentication, and they also maintaining the user credentials too. You don't need to have to store these user credentials and maintaining those things. They are uh, maintained user credentials and user info is maintained by these identity providers themselves. For examples are Keycloak, Okta, Auth0, and also WSO2 identity server. It is actually same as Auth0, and there's also a product called Asgardio, which is same as on web on top of WSO2 identity server. But mostly commonly used one is Auth0, which is a fine, and that is free, somehow free for most of the applications.
Uh, so please look into this identity providers like Port, at least or Zero, and how you can create authentication and authorization and maintain user credentials are uh, already implemented services can be integrated into your application. If I mean if you want if you just made the create an application that is not having any authentication at all, but you just need to there's no API security actually. If you just need to have a authentication to your application, authentication and authorization, this is just 2 or 3 line of codes that by importing the libraries they even uh, implement render the UI for login as well. If you go more to this option. And next one is very last one is extended API security using AI-based protection. We have already discussed this. We can identify these anomalies with the help of AI by trained machine learning and AI models. Uh, it's basically API gateway traffic is uh, monitored by their logs, and these logs are trained to machine learning and AI models, and we can uh, fine tune that to catch in those anomalies. Then we can work on those uh, potential threats and blacklist them. And that's how this artificial intelligence cluster, AI cluster, is working to blacklist the an anomaly after anomaly detected. It can blacklist those potential harmless nodes. So this is the end of the session. So this is the conclusion and key takeaways that you can get from this. So API security is multi-layered and crucial to your business, and API gateway is a central enforcement point that you need to implement your API securities in API gateway. And authentication and authorization. So this is the foundation, and choose appropriate method for appropriate application. I have told you that most common use that one is authorization code method for 2.0. If you want to use single sign SSO, single sign authentication, you may need to go with OpenID Connect or SED. And if you going to do a backend communication, you need to implement client credentials authentication. And if you're going to so there are there are own applications for each of the mentioned authentication and authorization methods. So please go each one by one and focus. Try to understand what is each application's each method's application. And we told about the rate limiting and why it is implemented. Then we are talk about the comprehensive protection like address over WSP top 10, and we haven't discussed anything regarding to that, but we gave some introduction, and we discussed about the malicious payload and bot detection and data leakage, and also we discussed about the design for security like OpenAI specification, and finally we talk about the integrating the IDPs, identity providers, and also integrating AI for complex environment to identify anomalies. So thank you. This is the uh, our presentation that I have prepared. Now I think you will be asked Q&A quiz that you need to answer. This all the quizzes answers can be answered from this slide that I have presented to you. So good luck and try to do best in your uh, quiz. Thank you.
Okay, thank you so much, Mr. Pasan, for that insightful and eye-opening session. Before we move on to the final part of our session, I would like to remind everyone there's a fun quiz coming after this, so please stay tuned. Now, let me take a moment to extend our heartfelt gratitude to our wonderful guest speaker, Mr. Pasan Abesekara, for sharing his invaluable insights and experiences with us today. Your talk on API security has truly been inspiring and eye opening for all of us. So, we chose this time to publish the token of appreciation to Mr. Pasan Abesekara. Thank you so much for your invaluable contribution.
Thank you.
Before we conclude, we have an engaging activity planned for you all. It is time for the quiz session. This is your chance to test what you have learned today and win amazing prizes. So get ready. The link will be shared shortly in the chat. Best of luck to everyone. Now the time is off for the quiz. Now we will share the leaderboard of our quiz. Then you can see the winners of our quiz today. So thank you to everyone who take part of this quiz. You all did a fantastic job. Congratulations to the quiz winners. You will be contacted soon by our organizing committee. So before we can conclude, I would like to express our sincere gratitude to our wonderful speaker, Mr. Pasan Abhisekara, for sharing his knowledge and experiences, and to all of you, our enthusiastic participants, for being a part of Wisdom Waves 1.0 today. Let's continue learning, connecting, and growing together. Until next time, stay curious, stay inspired, and keep riding the wisdom waves. Thank you and have a wonderful evening ahead.